We are now going to discuss how amino acids act as acids and bases. In the previous section, we discussed Zwitter ions. That is when, instead of having NH2, the amine has added an extra hydrogen. It's picked up an extra hydrogen from its lone pair on the nitrogen to make it NH3 with a positive 1 charge. And the COOH, which was originally carboxylic acid, has donated its hydrogen, giving it a negative 1 charge. Now we're going to discuss how this actually affects, how pH can actually affect how this happens. When it is at the appropriate pH, it's at the isoelectric point. It's a very specific pH for that particular amino acid. If we look at this chart, here we have names of the amino acids. Then we have the abbreviation of the amino acids. On the bottom, this is the PI. Those are the isoelectric points. If the pH that the solution is in, that the amino acid is in, is acidic, meaning the pH goes down, because remember, the lower the pH, the more acidic it is. It actually makes a positive ion. If it's more basic, meaning the pH goes up, it gives it a negative ion. You may find it beneficial to memorize this rather than have to think your way through every single time. However, I'm going to explain to you how you could think it through. So, if you're in an acidic environment, that means your pH goes down. It's lower, the pH is lower than the PI. PI is for the specific amino acid. And then if we have a lower pH than that, that means you're in an acidic environment. Which means that you have an excess of hydrogens. That, by definition, is what an acid is, something that gives off hydrogens. So when you're measuring pH, you're measuring how much hydrogen is there. So if you have a low pH, meaning more acidic, it means you have a lot more hydrogens. As a result, this CO right here, this carboxylic acid, even though at the PI it's a negative 1 charge, when it becomes more acidic and there's more hydrogen, it doesn't have the need to give off that hydrogen. It's not as willing to do that, so it stays there. Meaning that the only charge that this Zwitter ion has is that positive from the NH3. So pH is lower than PI. It's giving a plus 1 charge because of this amine. Opposite, if it's in a basic solution, that means the pH is higher than the PI. That means you have less hydrogens in the solution. So since you have less hydrogens, okay, the carboxylic acid is still going to go ahead and give away the hydrogen to add more hydrogens to the solution. However, since there's less hydrogens floating around in the solution, this NH2 isn't as likely to pick up a third hydrogen, so it stays NH2. So that's why at a higher pH, it's a negative 1 charge, because this still gives up the hydrogen, the NH2 just doesn't accept one. So as a summary, low pH, positive, high pH, negative. And it's low and high in comparison to the PI. So let's take a look at this. These are the same compound. They want to know what if the pH is above PI or if the pH is below PI. High pH means that it's basic. Low pH means it's acidic. That means extra hydrogens for the high pH, for the low pH, less hydrogens for the high pH. So, let's look at the basic one first. If it's a high pH, it's less hydrogens, which means the carboxylic acid will still go ahead and give off its hydrogen, but there won't be enough to accept it for the NH2. So, for the high pH, the pH is above PI, it's going to be number 2. For extra hydrogens, that means the carboxylic acid will not give up its hydrogen because there's too many floating around anyways, but there's plenty for the NH2 to snag one. So for pH below, meaning it's acidic, it's going to be a positive one for number 1. And that's how they got the 2 and the 1 there. Okay, we're going to ask the same question in a different way. The PI is at 6.0. That's where it's going to have that positive and negative at the same time. So at a pH of 3, that's less than, that's more acidic, which means there's more hydrogens. That means that the COOH will not give up its H, but there's still plenty of H's for the NH2. So that means it's going to be positive. At 9.0, that's more basic. That means you have less hydrogens. That means the compound is more willing to give up that hydrogen, but there's less hydrogens around to make that NH2. So it's going to be a -1 charge. And there's your answers again, +1 and -1. As I said before, it might be cumbersome to memorize, to try to think your way through every single time. However, you could just memorize the fact that if it's a low pH, it's going to be positive. If it's a high pH, it's going to be negative. That might be easier for you to do. And that is how amino acids react in acids and bases.